Good evening, all. So we should start the session in another 2 minutes. Hi, good evening, all. Am I audible? Okay, thank you. Yeah, now is it fine? Okay. So let us start the class. So today the topic is going to be on functions. Okay. So function is nothing but it is just a piece of code that has a specific task to perform. Okay, so that's it. So every function will have a specific task to perform, and that part of the code will be written in that function. So now, like, why do we go for function? Now, the first major reason why we go for function is the reusability. Okay, suppose you want to find the square root of a number. Okay, so inbuilt function is already there, but you want to implement your own function, suppose. So you're writing a function to find the square root of a number. So if at 10 places in the program, you're going to find the square root. Okay. So every time you should not be implementing the same set of code again and again 10 times, right? So instead, what we do is we just put that block of code, okay, in something called as a function. And every time we call that function and perform the task. Okay. So this is a simple example, the use of function. And it is better to have a single and a related action. Okay, so a name, suppose you're writing a function to find the square root, it is better to name the function as square root itself. Okay, so instead of creating confusions, like another simple example is you're writing a function to add two numbers, so you should not name it as multiplication, right? So it's going to perform addition, so name it as addition itself. So related actions should be there inside the function. So it provides like the first thing is reusability. Okay. So like instead of implementing it each and every time, you can just call it whenever it is needed. Second one is your program itself will become modular. So what I mean by modular is that like like every functionality of your code will be in a particular place. Okay. So for example, you are going to perform some 10 operations. Okay, so instead of writing all the 10 operations inside the main program itself, you just make it functional. Okay, so all the 10 operations in 10 different functions. So now what is the advantage of doing this is, if there is any error in your code, okay, you can easily find out the error, and it's easy to trace as well. So in a particular block of code, there will be an error occurring. So you just need to concentrate on that particular block instead of searching in the entire set of entire code. So you can just concentrate on that particular piece of code to correct the mistakes. Okay, in that way also, the functions are useful. Okay, so like there are like actually two types of functions. One is inbuilt function, and other is user-defined function. So inbuilt function means all the functions that are already present inside the Python compiler. Okay. So like input is a function, print is a function. Okay, like that lot of functions are square root, absolute. Okay, like that lot of inbuilt functions are there. Okay, so all those are inbuilt functions which are already implemented inside the Python compiler. The second one is user defined. Okay, so user defined means what we are writing. Okay, the functions which we write are called user defined function. Okay, so for example, if you want to find the sum of elements in a list. Okay, so okay, fine. Already that's a function called sum in for list. You want to multiply all the elements in the list. So what you do, you just put a function, and then you will write a loop, and then multiply all the elements and return that value. Right. So that is user defined. We can do our own logic inside that user defined. Whatever logic is preferable for us, that we can use. Okay. So this is all basic about function. Now let us go and see how to implement and how to write a function code. Okay. So first of all, we need to define the function. Okay, define the function means you are writing the logic, what that function or what the task a particular function has to perform. So that is called defining a function. Okay, so like there are simple rules. Okay, so like the function will always start with the keyword called def. Okay, def means definition. That's it. Okay, very simple. The short form of definition is def, so they have given it as def. And after this def, it will be followed by a name. Okay, a function name. For example, sum of two numbers. And this function name follows the same rule as the variable name. Okay, for variables we saw certain rules, right? So like it should not start with the number, it should not have special characters, it should not have space. All those rules are can be followed here as well. Okay, so like to make it more readable, what we have done is we have used camel case. Okay, so this is called camel case. If there are two or more words coming in a single word, okay, you're defining a function name like this, sum of two numbers, right? So sum, and one more thing is the first character should not start with the capital letter. Okay, it is actually not a rule, but actually it is a conversion. Okay, conversion in the sense, like in Java, sorry, not in Java, like in Python, all the classes names should start with capital, and rest everything should be in small only. Variable name, okay, function name, all those things should be in small. Okay, that is a simple conversion what we have to follow. Okay, so this is universally understood, that's why. Okay, so any programmer will understand that if a variable or a name is starting with capital, then it is called a class. Okay, so the next class we'll be seeing about class and objects. There I'll explain it more in detail. So this is one way of writing the function name, and you can also write it in snake case. Okay, so
So your
some,
video was
sorry, I've shared my
your
screen.
video was off. Oh,
Now is it okay?
no, no, sir.
Maybe you're not able to see my screen.
No, so once again I'll log it and log in.
What about others? Others, are you able to see my screen?
Yes, sir, we can see screen.
Okay. So sum underscore of underscore two underscore numbers. Okay. So this is also another way of defining the function name. Both are correct. Okay, whichever way you want, you can follow. Okay. And okay, followed by the function name, you have the open bracket and the close bracket. Okay, and inside this open bracket and close bracket, you can like a sum of two numbers, right? So you'll have two numbers as inputs. So a comma b. Okay, so how much ever arguments have to be passed, those many amount of arguments can be passed. There is no restriction in it. So there can be zero arguments as well. Okay, you can write a function without passing any arguments also. These are called arguments or parameters. You can use any of the names. Okay, arguments, parameters. And after this close bracket, it will be followed by a colon. Okay, this is called the function signature. Okay, so the function name. Okay, and you have the parameters for the function. And inside this, so now and so inside this function, you can start typing your logic. Okay, so here you're going to find the sum of two numbers. You can write the logic to find the sum of two numbers. So, and you can see that all the statements that are belonging to the sum of two numbers, okay, to this function should come with one space tab or one tab. Okay, one indentation. So, like just to give more clarity, you can write few print statements. Okay, so here you can see that there is a return statement. Okay, and then we can see we have written def here. So now what happens is this function like should return some value. Okay, it will perform some operation. Okay, what has been given to it, it will perform that, and it will return the overall outcome. Okay, whatever task it has performed, the final output it has to return. So suppose if there is no any return, what happens is Python by default will return none. Okay, understood. So this is the basic of function. So now how much hour function you want, you can write. But what happens is Python will execute only from the main function. So how will it identify whether you're writing a main function or not? Is that okay? There are two ways. One is like defining a main function. I'll tell about that later. Okay. Now other thing is whatever statements you write without the indentation belongs to main program, main function. Okay. For example, let me put a print statement. Okay. So now we return a simple function and then the main program. So here you can see all these statements come without any indentation, right? So this belongs to the main program. And one more important thing is that if all the functions should be declared before the main program. Okay. Why? Because it will not go and search after this. If there is any function call, it will not go and search after the program, after this function call. It will only search before the function call. So that is why it is mandatory to write the functions before the main program. Okay, I'll show you both ways. Okay, if I execute, it will throw error. I'll just show it to you. Now we should understand the flow here. So even though these statements are coming first, what happens? You can see the first output is inside main, which means that this is the first statement that is getting executed, right? After that, we have a equal to 5, then b equal to 10, and then we are making a function called sum of two numbers, and we are passing a and b. So now what happens is, like you can see a and b over here, and a and b over here also. So these two variables and these two variables, with respect to memory, both are different. Only with respect to value, both are same. Okay, I'll explain you with the memory sheet, then you will understand. Now once I make a function call, okay, sum of two numbers, now the control comes to this function. Okay, so here you can see there's a print statement inside some function, and that is being printed over here, and then it will calculate the sum and then it will return. Okay, the value that is calculated over here, a plus b, will be returned. And where does it return? It will again go back to the main program. Okay, and it will get stored in the variable called c, and we are printing that c, sum equal to c, and 15, we got 15. Okay, any doubts so far?
So can you take over again?
Sorry,
If you could please go over again.
once again. Okay,
Yes.
so function is just a piece of code to perform a particular task. Okay, and then the main use of functions is reusability and modularity. So reusability means every time we did not implement the same logic. Okay, if you're going to use a particular logic multiple times, you can just put it in a separate like area. See here also. Suppose I want to find the sum of two numbers. I did not write sum of two numbers each and every time, right? Suppose I want to give two more variables C, D, E, F, G, H like that. So to find the sum of two numbers, I can just make a call to this function, right? So this is called reusability. Modularity means like your program will get modularized in the sense like if sum of two numbers is one of the functions, it's like that if you have some 4 5 functionalities like finding square root, finding the maximum, finding the multiplication of two numbers, so like that you have some more functions. So what you can do is you can just make it functional in the sense you can make it each functionality in a separate function. So in that way your code becomes modular. Okay. And there are inbuilt functions and user defined functions. So inbuilt functions are functions that are already present in the Python compiler, and user defined functions are the functions that are written by the user. Okay, whatever functions we write by our own are called user defined functions. And we saw like so actually the rule for defining the function name is similar to the rule or is same as the rule for defining a variable name. Okay, both should be same. And always a function name should start with the keyword called def, which is nothing but the short form for definition. We are defining a function, right? So def, and you have the function name. So you can follow any of these like formats. So this is called camel case. This is called snake case. Okay, snake or camel, whichever format you want, you can use. And it is better to give a name which is precise to the functionality that is going to perform. Okay, instead of giving some junk names, you can give some correct names, opt names for the function. And you have the open bracket and the closed bracket, and within the open bracket and closed bracket you have the arguments that has to be passed. Okay, so this is sum of two numbers, so it requires two numbers to add, right? Okay, to find the sum it requires two numbers, so we are passing two numbers, we have to pass two numbers. So it can have any number of arguments. Okay, and it can have zero arguments as well. And after the close bracket, you have the colon. So always you have to understand that this colon is the start of a block. Okay, so even in if condition, we had a colon. For loop, we had a colon. While we had a colon. Okay, so in the next class, we'll be seeing about classes. In classes also, we'll be having a colon. Okay, so colon is always the start of a block. Okay, and after this, okay, this is how we will like this is called function signature. Signature means like the function name followed by the number of arguments. It's called signature. And below this, you have the function like the logic that the function is going to perform. And you can see all the statements that are belonging to this function come with indentation. Once we remove the indentation, then it will start belonging to the main program. Okay. And we should always remember that the function definition should be before the main program. Okay. Now let us see what happens if we write. Okay, so it simply says that function, okay, this sum of two numbers is not defined at all, but whereas we have defined it, right? So it does not see whether it is the function is defined after the code or after the function call or not. It just sees whether the function is defined before the function call. Okay, so this is the correct way, and this particular statement is called function call, and this is function definition. Okay. Now let us see with respect to memory. Okay. So with respect to memory, what happens is like you have to understand that the function works with the stack model. Okay. So what do you mean by stack model? Okay, so a stack is nothing but your last in, first out model. So last in, first out model. So what I mean by this last in, first out model, suppose you have a CD tray. Okay. So in a CD tray, you will have a small rod in between, right? So you'll be keeping on placing the CDs one above the other. Okay. Will you be able to pull out a CD which is at the middle? No, right? You cannot pull out a CD from the middle. So whichever CD you have put at the top, only that CD can be removed. That too, you have to remove it from the top, right? That is called last in, first out. Okay, that model only will be followed by this functions. Okay, so this set of code is your main program. Yeah, packed plates. Okay, and then you have packed based an example. Yeah, so like in buffet system and all, you'll be having packed plates, right? So if you pull out a plate, one more plate comes on top. Okay, and then the bangles of the same size only like women. Okay, so that is also an example of a stack. You cannot pull a bangle at the last, right? Only whichever is put at the first can be removed. Yeah. So now what happens is first, okay, only if there is a function call, okay, this particular memory will be created. Okay, so it's just a definition of the function. So what happens is if you don't call this at all, suppose if I commented this, now what happens is this particular piece of code will never get executed at all. So memory itself will not be allocated for this piece of memory, piece of code. Okay, so only if that's a function call, the memory will be allocated. Okay, I'll tell you how it is done. So this is the main program. Okay, and then it will check how much memory would be needed. So we have two variables and we have some set of instructions, a function call, all these things are there. So according to that, you'll have a memory allocated for the main program. Okay. So this is the main, suppose this is a CD tray, and then assume that you have inserted the main disk. Okay, main CD disk is inserted. Now it starts performing. Okay, the instructions would be start to perform. Okay, A equal to 5, and then B equal to 10, and you have the function call. Okay, sum of A comma B. So once it sees a function call, what happens? It checks how much memory will be needed for this function. Okay, so we have some print statement, some arithmetic operations, and then return. So according to that, and one more important thing is this A and B are different with respect to memory to this A and B. Okay, this A and B belongs to main program, and these two A and B belongs to the sum function. They share the same values, but not the same memory. You have to understand that. Okay, and you have the sum function here with A comma B as two parameters. Okay, so what is A comma B? Here you will be passing 5 comma 10. The same 5 comma 10 would be carried over here. Okay, let me write it A comma B over here, and here let me write 5 comma 10. So there will be a direct mapping. Okay, so the first argument to the first argument, second argument to the second argument. Got it? So A will take the value 5 and B will take the value 10. Okay, and you have C, which is equal to A plus B, and finally there is a return statement. So this will return 15. Now what happens is in this function, in the main function, I have written C equal to sum of 5 comma 10, right? See here, C equal to sum of 5 comma A comma B, which is 5 comma 10. So now what happens is once it returns back, this particular function value that is passed. Okay, now how will this statement get transformed to? Will get transformed to c equal to 15, right? So here from this function I'm passing 15, so this particular function will be replaced by 15. So now this will get assigned to c. The value of c becomes 15. So once it returns back, what happens is this piece of code will get, okay, will get like deallocated from the memory. Okay, so it is like removing a CD disk. So we have inserted this CD disk to perform some task. Once the task is done, we are removing it. Okay, this will get deallocated from the memory. Now the control comes back to the main program and the rest of the statements will get executed. So we have the print statement, right? So they will get executed. And once this main program task is also done, this will also get removed from the stack. So memory for main also will get deallocated. Okay. So this is how a function works. And I'll give you one more good example with one more function call. Okay. Suppose I'm making a function call to multiply. C comma, sorry. Yeah. C comma B. Or I'm going to okay. C comma B. So, okay. And I'm going to store it in D. Okay. So I will define multiply function. And so one more thing is it is not okay mandatory that we have to give the same variable names. Okay, so why we are giving same variable's name is just to avoid confusion. Okay, but that is not a rule that you have to like definitely give the same names. You can give any names. So I will give x and y over here. Okay, and this is going to multiply. I'll write some print statement. Return f. Okay, so can anyone tell me how will the function flow be? Yes.
So from main function, it will call the sum of two numbers function, and
Yes.
then when it will be inside the sum of two function, then it
Mhm.
will call the multiplication function, the mul function.
Yeah. So now what happens with respect to memory? There'll be a statement over here, right? Multiply function d is equal to multiply of c comma b. Okay, c is 15 comma 10. Now what happens? So this is a function call, right?
New memory will be created.
Yes. So where on top of sum. Okay, it is like inserting a new disk on top of the second disk sum. Okay, so multiply function on top of sum function. So here x comma y. Again, there is a direct mapping. Okay, the first argument with first argument, second argument with second argument. So x will take the value 15 and y will take the value 10. Okay, now we have some operations to perform. And finally it will, okay. So f is equal to x into y, which is nothing but 150 return 150, right? 15 into 10, 150. So now where does this return go? Will it go to some function or will it go to main program?
To some function.
Yes, very good. So this multiplication function was called from some function. Okay. So like what happens is multiplication function is called from some function. So it has to return back to some function only. It will not go to main function. So the only thing that it knows is from where it was called from. Okay. and the operations that it has to perform. So it was called from some function, so it goes back to some function. So the same thing, that exactly what happened over here. So this multiplication function will be replaced by the value returned. Okay, so this will get turned to d equal to 150. So the value 150 will be stored in d, and that is what would be returned here. So I put return d, so return 150. Okay, now this return. So once this multiplication function returns 150 to some function, this memory will get deallocated. I'll mark it red. Okay, and once this function also got executed after returning 150, this will also get deallocated. And once it prints the some value and all these operations are done, this memory will also get deallocated. Understood? Okay. Now one more question. Here I put f is equal to multiply of c comma b. C comma b. Okay. Now what happens?
Sir, sir, it will go to from main function. First, it will call sum of two numbers. Then from sum of two numbers, it will call mul function. The mul will return the value, return f. Then d will be printed. Then after execution of these two functions, again main function will call mul function, and this time mul function will return f to the main function.
Yeah, correct. Okay, so once this function flow is done, I have one more function called f is equal to multiply, and two arguments are being passed. Okay, so now what happens is these two memory has got deallocated. Okay, now if I call this function, so since these are deallocated, this is empty space now. So this multiplication function call will be put over here itself. Okay, since this memory is free. Understood, right? Okay, so this is an empty space now. Now whatever functionality has to be performed by the multiply function can be done over here itself. It need not search for a new free memory. Okay, so this visualization is important to understand recursion. Okay, that we'll be seeing in the later part of the session. Okay, just understand that whenever that's a function call, new memory will be allocated. Okay, unless and until the function is being called, memory will not be allocated. Okay, so how much ever function you want, you can define, but memory will be allocated only if that's a function call. Okay, fine. So this is the basic for function, and I hope you understood how it is working in the memory. Okay. Yeah. So now let us see the different ways in which functions can be implemented. Okay. So in Python, we have like 4 different ways in which functions can be implemented. Okay. One is the this is a normal way, like so here we pass two values and we read those values in two variables over here, two parameters over here. Okay, and like that it is direct, right? So how much ever arguments we pass, those many arguments we have here, and then that's direct mapping as well. Okay, this is the first type. Okay, which is called as required arguments. Okay, so first I'll just list down the types and then I'll explain one by one. Second type is keyword arguments. Third is default. And fourth is variable length arguments. Okay. So this is what is your required arguments. Okay, fine. So next is keyword arguments. Like here, I told you that. So we are giving the same name just to avoid confusion, right? Okay. So in Python, there's a feature called keyword argument where you can define your own variable name. Like so whatever variable name you are using in the main program, okay, and you want to you want to assign, or you want that same name to be like referenced in the function also. So in that case, we use default keyword argument. Okay, so I'll give an example, understand it better. Suppose in the main program, I have X and Y. And then I'm calling the sum function. And then I want the names of the variables in some function to be A and B. And I'm giving A equal to 5. Just give me a minute. Yeah, sorry, I'm back. So here I'm giving, sorry, A equal to X, not 5. So X can have any value, and I'm giving A is equal to X, and then B is equal to Y. Now let us define the sum function. So def sum of, so here like I'm giving A comma B. Let me check the value of A and B. So what exactly happens here is I'm passing A is equal to X. So now it will search for the variable A in this function call, in this function definition, and then it will assign X to that A. Okay, that is what will exactly happen. Now let us execute, and then after that, let us change the variable position and then see what happens. So the value of A is 5 and value of B is 10. Now let me change the positions of A and B. So I am giving B comma A. So you can see that in the previous execution, A was 5 and B was 10. Okay. And now here also you can see that A is having 5 and B is having 10. The same values. Why? Because so here in the normal function declaration, what happens? There will be direct mapping, right? First argument is first argument, second argument, second argument. Whereas unlike here, what happens? It will search for the variable A. So here A is a second argument, right? And in the function call, A is the first argument. So it searches for the variable A and assigns X to it. And here also, it searches for the variable B and assigns B to it. Understood? Any doubts here?
No, sir.
Okay. So one good example for this is like your separate equal to and then end equal to parameters are there, right? In print function. Okay. In print function, you have separate equal to, you'll give some value, and end equal to, you give some value, whatever value you want to end. So those two are also keyword arguments. Okay. We are defining what is end and what is separate. As simple as that. Okay. Fine. So this is your keyword arguments. And the third type is default arguments. Suppose you want to define certain values like without passing. For example, like you want the second value always to be 10 if nothing is passed in place of that. Okay, so I have the first value A, which can be any value, and I have the second value B, which is equal to 10 if B is not passed from the main program. Okay, I'll complete it and tell you, explain it again. So sorry. Okay, so what do you think would be the output?
15.
Yeah. So what happens here is you have only one argument passed to some, and the second argument I have not passed anything from the function call, right? So by default it takes 10 as the value. Sum is equal to 15. So now what would be the output?
5.
25.
Yes. So this default value will be taken only if you don't have the corresponding argument. So here this, if second argument is not present, then it will take the value as 10. If it is present, then what happens? Whatever value is passed, that only will be considered as the value. Okay. That's it. So like this, you can have any number of default values. And one important rule is that default arguments should be in the rightmost end. Okay. So you should not give first b equal to 10 and then after that comma a. That is not allowed. Why? Because you're not sure which is the default argument and how many arguments will be coming after, like how many arguments are default arguments, that is not sure, right? So
So,
for example, yeah.
so can we give two default arguments?
Yes, any number of default arguments can be.
So if suppose you have given A, B, and D you are writing now. So if I give A also some default value?
Yeah, that also I can give.
Okay.
You can have everything also as default values. Okay, I'll give 5 for A, B is 10, D is 20, E is 30. Okay, and C is equal to A plus B plus C plus D. Sorry, D plus E. Okay. So print off sum. So I'm not passing any arguments over here. So let me make it simple. Print off sum of 50. Okay. Print off sum of 50 comma 100. 50 comma 100 200. 200, comma 300. Okay. So if I don't pass any values, everything will be taken as default values. 5 plus 10 plus 20 plus 30. 65 would be the answer. Okay. And if I pass only one value, so only the first argument will be replaced by 50. And all other will be default values. Okay. 50, 60, 140 would be the answer for this. And like that it goes on. Got it?
So
Yeah, Sam.
I got it all right, but I want us to look at a situation where we are providing only one input to our function definition, but we want that value to be replaced by, let's say, E. So I want the 50 to go and replace the E. Is it possible to define it
No,
in
no, no,
such a
no.
way that
It,
you not,
in the
okay,
it is not possible because it will be in the same order.
okay. So you
First
cannot
or
jump the order.
no, you cannot change the order. If you want E to be replaced with like default value, then E should be the first.
Okay, okay, okay.
Okay, good question. But the order has to be maintained. Okay,
Thank you.
yeah. So next is variable arguments. So everyone understood, right? Any doubts?
So while passing, can't we write like a equal 50?
While passing?
In the second case, only
Second
one
case.
argument it's there, right? Can't we
Yeah.
write e equal 50?
Can we write B equal to 50?
Yeah, anything like that.
So you want to combine default arguments and keyword arguments.
Yeah,
Uh, let us try. I think it is possible. Yeah. Yeah, then Sam, you got the answer for this, for a question. So you want E to be replaced and just give E equal to 50.
Okay.
Okay, so yeah. And oh, correct. So I think suppose if the first argument is not default argument, okay, and then you have to give one argument at least, and then after that you can give default. You can combine default argument and keyword argument. So here I can give uh, yeah, I'll give 50 comma B equal to 50. And then here E equal to 100. So this sum I'll just remove. See here, that should be at least one normal parameter that should be passed. Okay. So now what happens? This A will expect some value, right? Because there is no default value for A. So this 50 is definitely allocated to A. And after that, you have this default values, and any of these default values can be replaced with the keyword arguments. So this is keyword arguments, right? So B will be replaced by 50, and then E will be replaced by 100 in the second case. Okay. Yeah. Good. Fine. So this is like a combination of required argument, default argument, and then keyword argument. Okay. And last type is variable length argument. Okay. So variable length argument, suppose you don't know how many elements you're going to pass. Okay. Suppose you're going to pass D is equal to sum of 1, 2, 3. Or you know how many arguments you're going to pass, but I don't want all the arguments to be given like different names. Okay, so for 1A, for 2B, so I have to declare 10 different variables, right? So instead of that, what we can do is def sum of, I just put a star and then give a variable name. Let's say A. So now what happens is all the values will get stored under the common name called A, and the type that takes is a tuple. Okay, the type this values takes is tuple. I'll just show you. Print of A and then print of type of A. Print of D. So I'm not returning any value here. So what do you think would be the value of D if we don't pass any value?
None.
Yes.
Sum of all numbers.
No, I'm not returning any value, right? So it will be none.
Okay, done is not there.
So this is the output, the first print statement, okay, which is print of A. And then we have the class or the type of A, which is tuple. Okay. And then you have D, which is nothing but none. Okay. So this is your variable length argument. And here also what you can do is, if you want the first few elements to be given names, for example, I want B to take the first value, and then C to take the second value, and then rest all should come under the name A. This is also possible. Now what happens is B will take the value 1, C will take the value 2, and all these other elements 3, 4, 5, 6, 7, 8, 9, 10 will come under the variable name called A, and the type would be tuple. Okay. Okay. So only from the third value it is stored in A. Understood? Fine.
So can you repeat this again?
Yeah. So here what happens is, if we want to give some few names, okay, sorry, few variables to be stored in arguments, and rest all the other, okay, to be stored in a tuple. Okay. So these names, all these values should come under, suppose it is like, for example, um, okay, suppose you're passing the student details. Okay. For example, you're passing the roll number, you're passing the name followed by marks. Okay. Roll number 1 and name JK, and you have the marks which are following. So I would always give a better mark to me. So I don't know how many subjects are there. Okay, and then so those many subjects marks are like, I know that there are 5 subjects, but I don't want to give separate names for these 5 subjects. I just mark it under, or name it under mark or marks. Okay, roll number, name. Now we understood. Okay, so all these 5 values will come under marks. Okay, so he can write roll number, and then total equal to, okay, okay, the sum is an inbuilt function, okay, which is see, like I'll explain. I forgot to tell one more thing. If there are like so sum is an inbuilt function, and in all these examples you can see that I'm writing giving the name as sum only, right? Now what happens is a overriding happens. Overriding means you are redefining the logic of the already present function. So the sum is an inbuilt function, so that is used to find this like for any sequence type it will find the sum and give to us. See, can this is an example. So mark is a sequence type, right? Tuple. So I want to find the sum of the elements of the tuple. So I use sum of marks. Very simple, right? So I need not write a loop and then add each and every element and then find the sum. So I already have a predefined function called sum. Okay, and I can use that. So here what happened? Some function I am writing my own logic. So now what happens is the already written function is being overridden by this function. Okay, able to follow, right?
Yes, sir.
Okay. So any doubts in this? Did you understand this?
Yes, sir.
Okay, fine.
So,
Yeah.
So that means there is no problem if we write use the any inbuilt functions name, then there will be no problem.
No problem, but it is not a good practice.
Okay.
You will get confused. Then suppose if you want to use sum of to find the sum of a list, then you will not be able to do that.
Okay.
Okay. Yeah. So now we have to understand what would happen if I pass an object. Okay. So what is an object? So all the sequence types that we create will be created as objects only, right? I explained you with the memory. What happens if you create a list? What happens if you create a tuple? So all those things we saw, right? So like if I pass an object to a function, let us see how it is behaving. Okay, so L is equal to, and then sum of L, or I'll just write. So fun, I'm just giving a short form for function, okay? Fun of L. Def fun of L1. And what I'm doing here is I'm putting L1 is equal to 3, 4, 5, 6. Print L1. And here I print L before the function call. And once again, I print L after the function call. So totally there are 3 print statements. Okay, now you have to tell me in which order the print statements will get executed. You can use the line number as a reference. And then what would be the output?
So first 1550.
Yeah, correct. Output?
1 2 3 4.
Yes. Then
and then 1547.
yeah, very good.
That will be
Okay.
3456,
Yes, correct.
and then 1552, which will be 3456.
Okay, very good.
Thank you.
Anyone else wants to give a different answer?
Sir,
Yeah.
first 1550 will be printed, which would
Okay.
be 1234, then 1546, which would
Mm.
be 3456, and
Okay.
then lastly 1552, which would be 1234.
Okay. Why?
Because the function, the function fun is not returning anything.
Yeah, but inside there are few like operations, right? Okay. So it's not returning anything. So uh, see, it is referring to L only, right? See, I'm passing L. This L1 is referring to this L only. Why doesn't the value change?
So maybe because it is not returning, and I think whatever is happening in just in that function only, not in the main program. So
Okay.
I'm
Okay,
not
fine.
sure.
So you're correct. Okay, but you have to put it in correct words. I'll tell you. See, like what happens is, so always you have to visualize with respect to memory. I think Pandi R is giving some answer. There is objects are so both variables are different. Yeah, correct. Both are different. See, with respect to memory, so I have 1, 2, 3, 4. The value of L 2097, right? So now what happens here is I'm passing 2017 only is being passed. Sorry, I mean 2097 only is being passed. So this L1, what it stores is just stores 2097, right? So it is referring to the same object, no doubt in this. But what happens in this statement is I am creating a new object, right? 3456 is a new object that's being created. And this object's reference is being stored in L1, right? So this L1 will get turned to 2102, which is not affecting L, right? Understood? So this assignment does not affect L. So that is why even here, if I print L after the function call, the same initial value of L, which was 1234, will be printed. Understood, everyone? See? Any doubts in this?
So if the function would return some value, then
Return some value. Okay, that depends on where you store. Okay, so suppose I'm returning L1. And where do you want to store this value? Where do you want to store this L1? Suppose you're storing it in L itself. Okay. Now what happens? This L will be replaced.
It
Okay,
will
with
overwrite, no?
yeah. So now this will be 2102 and this will start pointing to this new object. Okay. Fine. No, I'm not going to do this. Now let me do a small change. I'm doing L1 dot append of 7. Now what do you think would be the output?
Sir, it will append
Hmm.
7 to L, but again the last print L will be same as 1, 2, 3, 4, as in it won't change.
So append of 7, okay, will append to L1, right? You told L actually.
Yeah,
It will
so,
append to
sorry,
L1.
to L1, yeah.
Okay. Any other answers?
It will be 1, 2,
But,
3,
so
4,
the
7.
But L1 is not there in this.
so the first print L will print 1, 2, 3, 4.
Yeah.
Then the second print would be one for line number 1547. It would be 1, 2, 3, 4, 7.
7,
Yeah.
yes.
Correct.
And then the last print would be 1, 2, 3, 4.
Okay. Yeah, this is your answer. I got it.
Yeah.
Okay. So Guru Srikanth.
The last one, I think it will also be 1, 2, 3, 4, 7.
Okay. You think that is the answer?
Yeah, and that's the answer.
Okay. Fine. So that is the correct answer. It will print 1, 2, 3, 4, 7. Can you explain how on the Excel sheet?
Since we are not creating a new object, it will be pointing to the same address.
So L1 is also
2097.
2097 only. Okay.
Any
So just
changes?
forget about this. Okay. So now, like, this is also referring to the same object. So what I'm doing is I'm appending 7 to this object only, right? Okay, fine. So since L is also pointing to the same object, after coming out of this function, so if you print L, it will print 1, 2, 3, 4, 7. Okay. Understood? Bhumika?
Yes, sir.
Yeah. Okay. Fine. Very good. Now this is all about function. Now let us see about recursion. So to understand recursion, you should just remember the function flow. Okay. So this one you have to remember. Okay. So how new disks are being added on top of other. Okay. So just remember this. So now recursion. What is recursion? It is nothing but a function calling itself. So this is quite a famous definition for recursion. Okay. So, but actually what happens is a function doesn't call itself back. So whenever it sees a new function call, it creates a new copy of it, right? So like if it sees if some function call, a new copy of function, the sum function is being created. Whenever it sees a multiply function call, a new copy of multiply function is being created, right? So what happens? A function, actually function calling itself. So function calling a copy of itself. So it doesn't call it back. Okay, it'll create a new copy and then it'll call the new copy. Okay, a new memory will be allocated. Okay, for every function call. That is what is meant here. Okay, a copy, right? Fine. So now, like, let us see, like, what are the advantages of function recursion. Okay, so any iterative program can be written using recursion as well. Okay, so only advantage of recursion is that it looks simple. Okay, the code looks simple. So this is the only reason we go for recursion. It makes the code look simple and it makes the code become very, very small. Okay, because if the recursion call itself will take care of multiple internal calculations. Okay, so for recursion, you need a lot of visualization. Okay, you have to like imagine the flow. Okay, so initially it will be difficult. Only if you trace the code and see, you will be able to uh, like it will come automatically. Okay, so this is the only reason why you go for recursion. And with respect to time and memory, so I told that every iterative program, okay, every iteration that is looping, okay, can be converted to recursion. So with respect to time and memory, can you comment whether recursion is better than iteration or like not better? Anyone?
Sir, is the memory getting deleted after the function is executed?
Yeah, but initially it keeps on building it. So once the function execution is done, the memory will get deallocated.
Okay, then, sir, if we talk about, I'm not sure about this, but
Yeah,
if
please, no problem.
recursion can be better because the memory is deallocating after the function is executed, but for
Mhm.
iterative statements, the memory is not getting deallocated.
Mm, it is inside the main program itself, right?
Yeah,
So new memory will not be allocated at all for iteration. Only for recursion, new memories will be allocated. Only if that's a function call, new memory will be allocated.
yeah.
Okay. Okay, fine. I'll tell you. See, like with respect to time and memory, recursion is not at all better. Why? Because so every time you make a function call, a new memory gets created. A new block of memory will get created. So with respect to memory, it is not better. Okay, because it requires a huge amount of memory if the number of iterations is more. So if there are 100 iterations, then you can see there'll be 100 functions that will be created, and one by one it will get deallocated from the memory. Okay, so I'll just explain the flow for one recursion algorithm, then you'll understand it better. Okay, and then with respect to time, so I told that iteration can be converted to recursion, right? So how many ever iterations are happening, those many recursion calls has to be there. So if an iterative code runs for 5 times, and there will be the equivalent recursive code will have 5 recursion calls, which means that 5 functions would be created. Okay. So now with respect to time, so what happens? There should be switching, right? From one function, it has to switch to the other function, and from that function, a new function will be created. Memory allocation takes some time, and to shift from one function to other function, it takes another some more time. And once the function is done, it has to return back to the previous function. For that, it takes some more time, right? So with respect to time, also recursion is not better. Okay, so like the good practice to write iterative code, and just to make the complex program look simple, we go for recursion. That's it. Okay, understood, right? Why with respect to time and memory, this is iteration is better than recursion? Any doubts
Yes,
in
sir.
that?
No, sir.
And most important thing in recursion is your base condition. Okay, before that, I'll just show you the framework for the recursion. So def followed by the function, and you have arguments. Okay, any number of arguments you can give. I'll write args. Okay, and the most important part is your the stopping condition. Okay, so in an iteration, if you don't give a condition, what happens is it'll consider that always the condition is true, and then it'll lead to an infinite loop. I'll repeat again. In an iteration, if you don't give a condition, what happens is it'll consider that the condition is always true and will lead to an infinite loop. Okay, similarly here also, it's not simple call. So Pandiraj, I didn't get your question. You can unmute and ask the question, no problem.
Sir, when first condition is false, we just simply call the function again in recursion, sir.
Yeah, correct.
So that, while we call the function first, we use a variable that is already in the memory, so that we can't change. We simply change the value inside the variables. So
No. Actually, what happens is a new copy itself of the function will be created. It will not be referring to the same variables in the first function.
which means whenever we call the function again, the total memory will be deallocated and a new variable is created. Am I right, sir?
No. Whenever a new function is created, the deallocation will not happen. New memory will be created. Okay, I'll show you. I'll show you an example for factorial. Then you'll understand. I think after explanation of factorial, your question will be answered. Okay. So function, and you have the condition. Okay, if, and this condition is called base condition or exit condition. So in any of the terms you can use depending on the situation. Okay, sometimes it will be called as a base condition and sometimes it will be called as the exit condition. And then you'll have a return statement here. Okay, you can have any other logic also, some set of statements if needed. Okay, and followed by that you'll have the return statement. So return, you can even here it depends on the functionality of the program, functionality of the function. So if it requires that some value to be returned, then it will return some value, else it will simply return. It means it is returning null, none. Okay. And then comes your recursive calls. Recursive call or calls. We can also have multiple recursive calls in a single function. Okay, I'll explain that also. And return. This is very important. Return that recursive call or functions. So whatever this recursive call is returning, that has to be returned to the previous function, right? Okay, so that's why I put a return. So if you don't put this return, what happens is the next statement would be return none. If you don't put this return, what happens? By default, the Python function will return none. So if you don't put a return here, whatever calculation the recursive function has done, that will go waste because that is not going to be returned. None is only going to be returned. Okay, you should be very careful here. So it is return recursive function calls. So this is the skeleton of a recursive function. Okay. Now let us see how to define a recursive function. So the simple example, factorial. So what is 5 factorial? 128, right?
120.
Yeah. So 5 into 4 into 3 into 2 into 1. What is 4 factorial? 4 into 3 into 2 into 1.
24.
24. Yeah. So 3 factorial is equal to 3 into 2 into 1. And 2 factorial is equal to 2 into 1. And 1 factorial is equal to 1. And we have a special condition, 0 factorial is equal to, this is also 1. So this can be considered as a special condition, or this also can be considered as a base condition. So when do we call a particular condition as base condition is, using that particular value, we'll be able to derive all other values. Then that is called the base condition. Understood? So using 1 factorial, can we derive 2 factorial? So it is nothing but 2 into 1 factorial, right? So using 1 factorial, you derive 2 factorial. So now we know what is 2 factorial. So using 2 factorial, we can define or we can derive what is 3 factorial. It's nothing but 3 into 2 factorial. Got it? So now 4 factorial is nothing but 4 into 3 factorial. And 5 factorial is nothing but 5 into 4 factorial. That's it. Okay, the point at which it is starting, or the point at which you are able to derive all other cases, that is called your base case. Base case or base condition, whatever. So what is the general form? What is n factorial? By seeing this
n
little
into
bit,
n
what is,
minus 1 factor.
yeah, correct. So it is
n
n
into n
into,
minus 1 factor.
yeah, very good, correct.
n
n
minus 1
minus 1
factorial.
factorial. So if you're able to define the general form, then this becomes your logic. Okay. So now I'll tell you how to convert this into recursive function. So first f followed by the function name. Okay. Factorial. And we need one argument, which is n. Okay. We are going to find this factorial of n, right? So factor of n. So first we have to write the base condition. So if n is equal to 1, I know that the value is going to be 1. So if n is equal to, and I have a special case over here. If n is equal to 0, the value again it is going to be 1. So I can just combine these two cases instead of writing it in a separate case, because both are going to return 1 only, right? So I just combine these two and in a single statement, or n equal to 0, return 1. Okay, and that's it. Now I can write my own logic. So return n into fact of n minus 1. So this is your recursive code for finding the factorial of a number n. Okay, so f is equal to fact of 5, print of f. $120. Got it? I can also get it as an input. Zero factorial is 1. Okay, and 1 factorial is also 1. Understood? So this is your, like, this is how you will, like, try to convert, okay, so the logic into recursive code. So this is an example where you have a single recursive call in your recursive function. Okay, now let us see with respect to memory. So I have the main program. And in this main program, I have taken input as n, and then I'm calling the fact function. Okay, n, then fact of n. And then printf. Okay. So let us assume I'm passing fact of 4. Okay. Now, so what happens? It is like that's a function called fact of 4. So now it refers. So here I have the definition for fact. So it has an if condition on return statement and some logic with the function call. Okay. So fact of 4 will be called. Now what happens? So this if condition, So I need not write all the condition statements. Okay, I'm just writing whatever will be executed, that all I'll write. So here the if condition is false, so these two statements, okay, will not be executed. So now what happens? It will return n into fact of n minus 1. So here return, here n is 4, right? So 4 into fact of 3. So a new function call, right? So now what happens? A new block of memory, and here the fact, the argument that is being passed is 3. So here return what? 3 into fact of 2. So again, new function call. So fact of 2, right? Return 2 into fact of 1, right? So now again a new function call. Fact of 1. Now what happens to the if condition? Comes true, right? So n is equal to 1. So here n value is 1. So the if condition becomes true. So what happens? It will simply return 1. So where does it return? It will return to this particular function, this fact of 1 function call. So this return statement will be replaced by return 2 into 1, which is equal to 2. So once it returns back, this memory will get deallocated. Okay, and here return 2, right? Now it will come over here. So this is return 3 into 2, which is nothing but 6. Okay, once it returns to fact of 3, this function will also get deallocated. Okay, and just mark everything as red. Now here this return 6, this fact of 3 will be replaced by 6. So return 4 6s are 24. So this will get deallocated after returning, and now this value will get returned over here. This is nothing but f is equal to 24. So after returning, this memory will also get deallocated, and the print statement, and after that this main memory will also get deallocated. So this is your recursive flow. Whenever there's a function call, a new block of memory will be allocated. And so again, it will not be referring to the same value in the previous function. In the new function, new variables will be created, and we'll start making use of those variables. Okay. Understood, everyone? And Pandiraja, is your question answered?
Yes, sir, clear.
Okay. Fine. So this is the function call. Okay, this is a recursive function, the single function call. Okay. Now another example is, okay, this is also a classic example. It is Fibonacci series. Okay, finding the Fibonacci nth Fibonacci number. So you know the Fibonacci series, right? So we can define it in two different ways. Either it can start from 1 or start from 0. We'll start from 0 itself. Okay, 0, 1. These two are the starting numbers. So it is nothing but the sum of the previous two numbers, right? So 0 plus 1 is 1. Now to find the fourth number, we have to add the previous two numbers, second number and third number, just 2. And 3, 5, 8, 13, 21, and it goes on. So this is your Fibonacci series. Okay. Now let us start index also. There are two options. Okay, either you can start from 1. This can be the first number, second number, third number, like that, or you can also define this 0th number, the first number, the second number, third number, fourth number, fifth number, sixth number, like that we can go on. Okay, as per our assumption, Fibonacci series is starting from 0 and the index is starting from also starting from 0. Suppose I want to find the fourth number. Okay, so let us see how the Fibonacci number works. So here, if I want to find the fourth number, I should know what is the second number and the third number. Okay, again, if I want the third number, I should know what is the first number and the second number. If you want the second number, I should know the 0th number and the first number. And we should know at least two numbers. Okay, only if you know the two numbers, we'll be able to generate rest of all the numbers. So in this case, the generation happens with two numbers. So there'll be two base cases. Okay, so one is 0, another is 1. Okay, so if n is 0, I should return 0. If n is 1, I should return 1. Right? So these two are going to be my base conditions. And my logic is nothing but, okay, nth Fibonacci number, okay, f of n is equal to sum of previous two Fibonacci numbers, right? So f of n minus 1 plus f of n minus 2. This is your logic, and these two are the base conditions. And that's it. Okay. Now let us see the implementation. So def fib of n. So I'm going to find the nth Fibonacci number. And I have two base conditions, right? So if n is equal to 0, and can we write it in a single condition instead of writing it separately? If n is equal to 0, return 0. If n is equal to 1, return 1. Can we combine these two into a single condition? Is it possible?
Yes.
How? If, what is the condition? N equal to 0 or n equal to 1, return what? Yes, very good. Return n itself. That's it. Okay, I'll remove these two conditions. See, if n is equal to 0, return 0. N is equal to 1, return 1. So it is returning n only, right? Okay, as simple as that. So we have the combined condition over here. And then return fib of n minus 1 plus fib of n minus 2. That's all. So this is your Fibonacci series code. Okay. So the fourth Fibonacci number is 3. Seventh Fibonacci number is 13. Okay. So we got. So now let us understand it with respect to memory. So now I'm not going to write it like this. Instead, you can see here. So now Fibonacci of 5, right? Or let us take 4 itself. Okay. 5, no problem. So it will, you have to understand how the memory flow is going to be. So now to find out f of 5, I need f of 4 and f of 3, right? So to find out f of 4, I need f of 3 and f of 2. So here the execution is going to be serial. Okay, there is not going to be any parallel execution. So what happens here is, while this f of 5 is calling f of 4, this f of 3 will be idle. This will not be called at all. Once it returns back to f of 5, then the f of 3 will be called and the operations will happen. Okay, till then f of 3 is not going to be called at all. Okay, so similarly here, this f of 4 will call f of 3 first. Once it f of 3 returns back some value, this f of 2 will be called. Till then f of 2 will be idle. Okay, so for f of 3, f of 2 and f of 1, and for f of 2, f of 1 and f of 0. Okay, so now let us see the flow. First f of 1. So f of 1 is having a defined value, right? So if n is equal to 1, I'll return n itself. So 1 will be returned. So the left recursive call has returned 1. Now comes to the right recursive call, f of 0. So this is also a base condition, so return 0. So now I got the left recursion call value and right recursion call value. So the functionality over here is to add these two values and then return, right? So 1 plus 0 is 1, and this will be returned to the previous function call. Now again it comes back to f of 1. The value is 1, and that 1 will be returned since it is a base condition. And here left value, right value, both will be summed up and then returned to f of 4. The left recursive call is done. Now comes to the right recursive call. Now what happens is f of 2, right? So this is very important. Even though the f of 2 is already been calculated by making these function calls, it will not recognize that the function is already been called and the calculation is already done. Instead, what it does is it performs the same operation once again. So f of 1 and f of 2. So this f of 1 will return 1, left recursive call, and f of 0 will return 0, the right recursive call. Here you have 1, and this is 1. So 2 plus 1 is 3. So 3 will be returned here. Okay. And f of 3. So what happened in f of 3? This many amount of code is there, right? All these will get executed once again. So I'm not going to show it again. I'll just write it here. Okay, understood? So this f of 3, all these calculations will be done once again. And then this will finally return. Sorry. Only f of 3, right? Okay, so this will return 2, and then 2 plus 3 is 5. Okay, this 5 will be returned to the main program. So this flow you have to understand. So first f of 5. So this is the flow. F of 4, f of 3, f of 2, f of 1, and the right recursive call f of 0, and right recursive call of f of 3, f of 1, and it goes to f of 4, and here f of 2 will get evaluated, returns back to f of 5, and f of 3 again. So if there are two recursive calls, you can see a tree kind of structure is coming, right? And you can see there are two branches. So if there is a recursive call, okay, two recursive calls in a single function, and you'll have a tree kind of structure with two branches. If there are three recursive calls, then what happens? There will be three branches in this tree kind of a structure. Okay, fine. Understood? So if it is a single recursive call and this linear function call would happen. Okay, if there are multiple recursive calls, then branching would happen. That's it. And one most important thing is, okay, so the execution will be serial. Okay, that'll be not parallel execution. Understood this, right? Any doubts in this?
No doubts.
Okay. So we'll see one more interesting example. Like, I hope we all know what is the combination problem or combination, right? So it's nothing but NCR. So what is the formula for NCR?
n factorial by n minus r factorial into r factorial.
Yeah. So n factorial divided by r factorial
N minus r
into
factorial
n minus r
into
factorial.
n minus r factorial.
Yes. Very good. So this is the formula for NCR combination problem. So now there is a recursive formula for combination problem. Okay, so this is normal formula. The recursive formula is NCR is equal to n minus 1 CR plus n minus 1 CR minus 1. So this is the recursive formula for combination problem. So just to validate this, okay, let us take an example 6C4. So what is 6C4? N minus 1 is n is 6 and then C is 4, right? So what is n minus 1? 5. Okay, 5C4 plus 5C, sorry, yeah, 5C3. So can you quickly evaluate and tell me whether LHS and RHS are equal by using this formula? So using this formula, tell me what is 6C4. Again, using this formula, tell me what is 5C4 and what is 5C3. Please do a quick calculation and tell me what is 6C4.
15, I think. 15.
Okay, very good. Is everyone getting the answer? 15? What is 5C4?
10. 5. 5C4 5.
5. And then 5C3?
10.
Yeah. So like you can just do a quick calculation and see. Okay. So just you have to find the factorial three factorial numbers and then you have to divide. You will get the answer. So 64 is 15, 5C4 is 5 and 5C3 is 10. Okay. So this 15 is equal to 15. So LHS and RHS both are the same. So it's just to validate whether this program is correct. That's it. Okay. Whether this statement is correct. That's why we did a small calculation. So fine. So we saw that this is correct. Now let us try to convert this to a recursive program. So to convert to a recursive program, the first main thing is you have to define the base condition. Without the base condition, you're not going to proceed with recursive code at all. This is the basic rule. So here the base condition is going to be like if n and r are going to be such and such values, we have a defined output. For example, if n is equal to r, what is the output? What is the NCN?
1.
Yeah. So NCN is always 1. Whatever might be the value of n is value is going to be 1.
That
So
is
like
equals
that.
to NC not.
Yeah, correct. So if n or okay, so r is equal to okay, I mean what is NC1?
N.
Yes. So NC1 is n. What is NC0?
1.
1. So this is enough. With these three base conditions, it is sufficient. We can derive the recursive function, and we have the recursive logic over here. Okay, fine. So now what you're going to do is you're going to convert this to a recursive function. Okay, so def combination of, we have two parameters, n comma r. Okay, and we're just going to convert these to base conditions. That's it. Okay, so here n is equal to whatever it is n, and then here r is equal to n, right? So if r is equal to n, and you have one more case where the value is 1, right? So r is equal to 0, return 1, and we have one case where the value is 1. Okay, so if r is equal to 1, return n. Okay, so we have defined the base conditions. Now combination problem, and now the recursive call. Okay, so return combination of, so here it is n minus 1 comma r, right? So in place of n I'm going to pass n minus 1, and in place of r it is r only, and then plus combination of n minus 1 comma r minus 1. That's it. So the code looks simple, right? But the internal calculation you have to understand. Okay, so okay, this is the recursive code. So imagine how lengthier the normal iterative code would be. So you should find the three factorial numbers, factorial of three numbers. Okay, and then you have to perform one multiplication and one division. Okay, so all these things you have to do. So here instead the code is only 3 lines. Okay, so n is equal to int of input r is equal to int of input, and then print combination of n comma r. Okay, 6 4 got 15. Understood? Okay, so we'll get 5 4, answer is 5. 5 3, answer is 10. Okay, so keep this as a base. Okay, now what you're going to do is, I hope a few of you would have understood and few of you would not have understood. Now your assignment, what you're going to do is, so we saw the recursive flow for Fibonacci number, right? So in the same manner, okay, what you're going to do is you're going to find out, or you're going to trace the code for trace the above function for n is equal to 6 and r is equal to 4. Okay, if we apply n is equal to 6 and r is equal to 4, so you can see there are two recursive calls. So you should like just write down the flow. Okay, just take a sheet of paper. Okay, turn it into landscape, because you will have an enlarged tree kind of a structure. Okay, so you should like make recursive calls. Okay, whenever that's a function call, left function call, right function call, like that. Okay, and from this function call again there will be two more function calls. So exactly similarly like this. Okay, you just trace the code and then see that you're getting the same output 15 as the answer. Okay, so this is your assignment. Okay, fine. So that's it for today. Like any doubts? Understood today's topic?
Yeah,
So
except that there are a few things we would have to go and look at again.
Okay, okay. You will have the YouTube link also. You can just refer this.
Sure.
Okay.
And sir,
Yeah.
in terms of development, anyway,
Okay.
I have PyCharm, but I realize you use VS Code a lot. Can you tell us briefly what are the advantages of each over the other
No, actually,
and what you recommend?
I use only VS Code, and then for execution, I use the terminal. That's it. So I don't prefer any other tools. So there are a lot of tools. Okay, like PyCharm, whatever you told. Normal IDE also you can use in Windows and all. You have the Python IDE itself, and then you have Anaconda. Okay,
Jupyter.
Jupyter. Yeah. So
So why don't you run the codes from the VS Code prompt
this
and normally you run from the terminal?
because
Is there any
I
special
got
reason?
no, nothing like that. I got used with running with my own terminal. That's why. So even
Okay.
here you have the your own terminal. See if I run, it'll get executed here. Okay, but I like running in that terminal. That's why.
Okay. Okay. And also the question I was discussing with you the other time, I've solved it, so you can just check.
Okay, okay, definitely. I'll do that.
But I realized that for the day two, you would have to solve all the three questions within the time frame before
Yeah, yeah, correct.
it is recorded.
So for ISS, you have a time frame.
Yeah.
Mm.
So if you're not able to finish the three within the time frame, you would have to come
You
back
can,
again.
yeah, you can take any number of attempts. Not a problem.
Okay.
So only
Now
thing is
it
you have.
means that I've solved the question one, I've solved the question two, but anytime I go, it's like I don't have anything in question one and in question two. So I have to
Yeah. So you have
keep the
to
code and
correct, correct.
code all of them within the time frame.
Yeah. Okay. So any other doubts? Anyone?
So, I had a doubt in the previous last time which you in the I analysis also there is one option on eBox. So can I give you the code? You can tell the output I'm not able to follow.
Okay. You want me to open iAnalyze? I can hear a
No,
lot of noise from
I'll
you.
give you. I'll give you. Just a second.
Okay.
And also, sir, the live access, you haven't given us feedback on that. You said you check.
Oh
And go back.
no. Yeah. Okay. Now itself I'll put a message. You just ping me in WhatsApp, no Sam. Just remind me in WhatsApp. I'll ask and tell.
No problem.
Okay. So what will be the output for the following Python code snippet? Regular expression. Let me open. I analyze. Which question? Last one.
Last one.
What will be the output for Python snippet? RE. So ERR E star E dot R, right? So which means this is matching. This is a string, and you have one matching character, right? So the search will return some value. So it is not equal to none. So this condition is true. So it comes inside, right? So str equal to re dot sub of r slash d capital E, okay, 3, right? So this one is matching, right? Comma r of hash slash 1. So hash slash 1 means this will be replaced by code hash slash 1 string 2. Okay, let us execute and see. Did you execute it and see?
No, sir.
So E followed by 3 digits. This one. Okay, and then it is substituting that with hash slash 1. Okay, I'll just check and tell you. I'm not able to get it right now. So this only this E is being replaced by hash. Okay, I don't know how is this happening. So maybe slash 1. So there is, I think, some meaning for this is there, slash 1. Okay, I'll check and tell you. Okay. Yeah. So any doubts? Any other doubts? Anyone?
Sir, in day 3, I practiced. I wasn't able to pass all the test cases. So,
Day 3.
Sir, there are certain questions in I practice. matlab, I have seen that if I write a code and if I run there in eBox, it gives some errors. But the same code, if I write in PyCharm, it passes there. So
So
can you?
okay, actually, okay, I think Python 3 only is you're using, right?
Yes, sir. Python 3.
Then it should work fine only. So what kind of error you're getting?
Generally, it doesn't pass fully. Like there are test cases. When you validate it, it gives 50% pass like this. So in
No,
PyCharm,
that is because of the internal test cases at the back end.
okay,
So
it's I think even whatever question they have asked, and even a slight error in is there, like typing
yeah,
mistake also, and then
correct.
also it
That's
gives.
why that validate button is there. If you validate, you will get all the mistakes. That mistake is called presentation error. Like you give you suppose if there are any spelling mistakes, okay, or additional characters you have given, you have left out some characters. Then that is all. So see, at the back end it is just string matching. Okay.
Okay.
So string matching means whatever output you're getting will be checked with the output that
Question.
is already feeded.
Okay. Okay.
Okay, so if you even leave a full stop, that will also be considered as a mistake.
Yes, even one of the questions it is case sensitive also, I think.
Yeah. No, case sensitive, it's not a problem. Only in the validation will throw it will get accepted. But only thing is you should not leave any character or you should not add more characters. That's it. This problem,
yes, sir.
what is the doubt?
Uh,
In
it's
submission or logic?
I'm getting an EOF error, sir. I don't know what it is. EOF error.
End of file error. I think you are. Okay, you send me a screenshot in WhatsApp. I'll check and tell you.
Okay.
Okay.
Maybe can you check my code, sir? Okay, I'll send it to WhatsApp.
Yeah. If you have submitted, I can check. If you have not submitted, I will not be able to check because once I have the submission, I can check.
I submitted it.
You have submitted. Okay. Tell
Yeah.
me your username.
Srikanth, SRIKNH. Yes.
This one, right? Yeah.
Yes, sir.
Which version?
Day 3. Email.
Once it finds it is invalid, you should stop there itself.
Okay.
So you're proceeding with the next one. Enter the number like that. That's why it is throwing end of file.
Okay.
See, after this, there's no input at all
Yeah.
because it is telling that it is invalid move. Okay. Just check for invalid move.
Okay.
Okay. Any other doubts? Okay. So we shall wind off and then we can meet in the next class day after tomorrow. Thank you.